Good afternoon. So today I'm going to explain about heat, explain the chapter about heat from the ninth standard. First of all substances in our surroundings are made up of molecules. These molecules are generally at motion and possess kinetic energy. At the same time, each molecule exerts a force of attraction on other molecules and so the possess potential energy. The sum of the kinetic and potential energy is called the internal energy of the molecules. This internal energy, when flows out, is called heat energy. This energy is more hot substances and less in cold substances and flows from hot substances to cold substances. In this lesson, you will study about how the heat transfers take place. Also, you will study about the effect of heat, capacity, change of state, and latent heat. So first of all, types of heat transfer: conduction, convection, and radiation. So conduction, the process of transfer of heat in solids from a region of higher temperature to the region of lower temperature without the actual movement of molecules is called conduction. In solids, molecules are closely arranged so that they cannot move freely. One end of the solid is heated, molecules at the other end heat energy and vibrates fast as their own position. These molecules in turn collide with the neighbor molecules and make them vibrate faster so the energy is transferred. The process is continuous still at the molecule in the heat energy. Conduction in daily life. Metals are good conductors of heat, so aluminum is used for making utensils like cook food quickly. Mercury is used in the thermometers because it is a good conductor of heat. We wear woolen clothes in winter to keep ourselves warm. Air, which is a bad conductor, does not allow our body heat to escape. Convection. Convection is the flow of heat through a fluid from places of higher temperature to a places of lower temperature by movement of fluid itself. So convection in daily life. Hot air balloons. Air molecules at the bottom of the balloons get heated by a heat source and rise. As the warm air rises, cold air is pushed downward and it is also heated. When the hot air is trapped inside the balloon, it rises. Breezes. During the daytime, the air in contact with the land becomes hot and rises. Now the cold air over the surface of the sea replaces it is called sea breeze. During nighttime, air above the sea is warmer as the warmer air of the surface of the sea is cooler above the land moves towards the sea. It is called land breeze. So winds. Air flows from air area of high pressure to an area of low pressure. The air molecules over hot surfaces rise and create low pressure. So cooler air with high pressure flows towards low pressure. This is caused wind. Chimneys. Tall chimneys are kept in kitchen and industrial furnaces. As the hot gases and smoke are lighter, they rise up at the atmosphere. Radiation. Radiation is a method of heat transfer that does not require practices to carry the heat energy. In this method, heat is transferred in the form of waves from hot objects in all directions. Radiation can occur even in vacuum, whereas conduction and convections need matter to be present. Radiation consists of electromagnetic wave traveling at a speed of light. Thus, radiation is the flow of heat from one place to other by means of electromagnetic waves. Transfer of heat energy from the sun reaches us in the form of radiation. Radiation is emitted by all bodies above 0 K. Some objects observe radiation and some other objects reflects them. Radiation in daily life. While our light colored clothes are good reflector of heat, they keep us cool during summer. Base of cooking utensils is blackened because base black surface absorb more heat from the surrounding. Surface of airplanes is highly polished because it helps to reflect most of the heat radiation from the sun. Next, change of state. The process of changing of substance from one physical state to another at a definite temperature is known as change of state. For example, water molecules are in liquid state at an all temperature. When water is heated to 100 degrees Celsius, it becomes steam, which is a gaseous state of matter. On reducing the temperature of the steam, it becomes water again. So, on reducing the temperature, it becomes water again. It will reduce the temperature further to 0 degrees Celsius. It becomes ice, which is a solid state of water. Ice on heating becomes wave again. Thus, water changes its states from there is a change in temperature. There are different such as process of changing in state of matter. Next, melting. Freezing the process. Freezing the process in which a solid is converted to liquid by absorbing heat is called melting or fusion. The temperature at which a solid changes its state to liquid is called melting point. The reverse of melting is freezing. The process of which a liquid is converted to a solid by releasing heat is called freezing. The temperature is at which a liquid changes state to solid is called freezing point. Next, boiling condensation. The process in which a liquid is converted to vapor by absorbing heat is called boiling or vaporization. The temperature at which a liquid changes its state to gas is called boiling point. The process in which a vapor is converted to liquid by realizing heat is called condensation. The temperature at which vapor changes its state to liquid is called condensation point. Boiling point as well as condensation point of water is 100 degrees Celsius. Sublimation. Some solids like dry ice, iodine, frozen carbon dioxide and naphthalene balls change directly from solid state to gaseous state. Because liquid in this process is solid is converted to gaseous state is called sublimation. Various stages of conversion of stage of matter by heat with the corresponding change. Heat capacity or thermal capacity. Now you are familiar with specific heat capacity. It is the heat required to raise the temperature of a unit mass of a body by 1 degree Celsius. But the heat capacity is the heat required to raise the temperature of the entire mass of the body by 1 degree Celsius. Thus, heat capacity or thermal capacity is defined as the amount of heat energy required to raise the temperature of a body by 1 degree Celsius. It is denoted by C. Quantity of heat required. Heat capacity is equal to raise in temperature. Next, specific heat capacity. Specific heat capacity is the amount of heat energy reduced to raise the temperature of 1 kg of substance by 1 degree Celsius or Kelvin. From definition, specific heat capacity C is equal to heat capacity by mass. So heat supplied by mass kg into change in temperature. So unit is Jk or J by C. Next, thermal capacity. Thermal capacity is denoted by the letter C, amount of heat Q needed to raise an object of temperature by 1 degree Celsius. So here you can see the equation of the C and units. Q is energy of joules. Delta T is the temperature change in C or K. Points to remember. Heat is transferred from hot region to cold region. Heat is transferred in three forms: conduction, convection and radiation. Conduction takes place in solids, convection takes place in liquids and gas, radiation takes place in the form of electromagnetic waves. Depending upon the temperature, pressure and transfer of heat, matter is converted from state to another. Thank you.